Good day and welcome to the Math Salon. I'm Dr. Emmanuel. We're going to look at a paper 3 question on advanced level mathematics, and this will be about probability of events. So the question that we have here is the events A and B are such that the probability of A occurring is 2 on 5, probability of B occurring is 1 on 5. And this probability of A given B, so this is a conditional probability, is equal to 1 over 4. Find A, probability of A intersection B, probability of A union B, probability of A given A complement or A prime, because sometimes A prime, the complement of A. So as far as events and probabilities are concerned, sometimes it's best described using a Venn diagram. For example, I'll just show something here to illustrate. So I have here, let me say I have an event A there and another one B. And this is my universal set here. So looking at this particular question in hand, we are asked to look for P of A intersection B. When you are given a question like this, the most important is look at the information given to you. So what are we given in this question? We are told P of A is equal to 215. P of B is equal to 115. And P of A given B is equal to 1/4. So my first question A says we should look for P of A intersection B. So this actually means the probability that the event A and the event B occur. But this is in an order so that we would see that there's some condition. This can be expressed as a compound probability. That means we can write it as P of A multiplied by P of B given A. See here. So if I write P of A here, then this part takes into account what has already happened. So this is P of A multiplied by P of B given that A has happened. So don't reverse it. So it's not A here given B. That's not correct. Of course, the other version exists. That is P of B times P of A given B, because B has already occurred here. Both of these forms will provide you the correct answer, the same one. So it's just left to look at what is given to you and decide which of these to use. For example, in this question, we are given P of A given B. So it means the second option is the one that will be the preferred one. So that means my P of B, which is given as 1 divided by 5, multiplied by P of A given B is 1/4. And this is equal to 1 on 20. 1 times 1, 1, 5 times that. So this actually, this part here. So the probability that this part occurs is 1 divided by 20, which means A and B occur. So for the other situation, we are going to look at P of B, that's a B, P of A union B. So this is the probability that A or B occur. The general form of this, A or B, you know the union of two means you actually write the elements without repetition, which means actually the intersection has to be only once, not twice. So basically then this would be like the probability of A, everything with A, plus the probability of B, and then we remove that intersection part because it's otherwise it will be counted twice, minus probability of A intersection B. So this is how we get this from here. So actually it will be something like this. So this is the A union B type of probability that we'll be looking for here. So in this case, we have our P of A that's given to us 2 on 5. 2 on 5 plus 1 on 5 minus P of A intersection B. We just did that now. That's 1 on 20. So if I look at the lowest common multiple of this, 3, I'll say this is 20. 20 divided by 5 is 4. 4 times 2 is 8. 20 divided by 5 is 4. 4 times 1 is 4 plus 4. Minus 20 divided by 20 is 1. 1 times 1 is 1 minus 1. 8 plus 4 is 12 minus 1 is 11. So I have 11 here on 20. So that's the probability of A or B, the event A or B occurring. We go to the C part here. Just to get some space. So for the C, we have to look for the probability of B given A complement. So if I just do back my stuff then. So this is A here, if I just move B here. So this is A, and the rest is A complement. The rest is A complement. So that's A there, then this is A complement here. So if you look at this and look at this compound version that I showed you, you see that they have some relationship. You see part of this looks like this. So I would maybe let you see if I have the probability of A complement intersection B, then I can write it as a compound probability as P of A complement times P of B given A complement. So based on this, I can actually fix, because I need this one, I don't want this one. So I can divide both sides by P of A complement, P of A complement, and this will go off with that. I have what I need. So it means my P of B given A complement is equal to P of A complement intersection B divided by P of A complement. So what we are left to do in order to calculate this is look for this, and then we are done. So you already see the probability of A plus the probability of A complement is everything. So it should be 1. That means the probability of A plus the probability of A complement should be equal to 1. That means the probability of A complement is equal to 1 minus probability of A. The probability of A is 2 on 5. So this is 1 minus 2 on 5. And that's equal to 3 on 5. See? Because this is 1 on 1, and you do that, you get 3 on 5. So I already know my denominator, I need the numerator. So to get the numerator, I'm going to show you a small trick here. We already agree that the union can be written as A union A complement. See, if I take all of this together, so this or this together, then you get U. So I can write this as this, because that's all what is. I can split my universal set into A, and the rest that is not A. I can say A intersection B. So my union, the union intersection B can be written as A union A complement intersection B. B is an event that is within the universal set, so the intersection would just be B, because B is a subset of U. Here I can open this up to be A intersection B union A complement intersection B. If I take the probability of B here, this will be equal to the probability of A intersection B plus the probability of A complement intersection B minus these two are disjoint. They are mutually exclusive, so this part will not exist. So the probability of the intersection is 0. So we are left only with these two. This is what I'm looking for. So I'm left just to take this to this side. So P of B minus P of A intersection B is equal to P of A complement intersection B. You don't need this to show every time. I just try to illustrate it so you understand how it comes about. So if you remember, you can just use it at this step. So my P of B is 1/5 minus P of A intersection B, that is 1 on 20. 1 on 20. And that's equal to, we have the same idea again. 20 is the denominator here for our lowest common multiple. And that's going to be 4. So 20 divided by 5. 20 by 5 is 4. 4 times 1 is 4. Minus 1. And that's 3 on 20. So if I just come here and put my information, the one I know, I have 3 on 20 divided by 3 on 5. And that's equal to 3 on 20 multiplied by, I invert that to become 5 on 3. 3 here goes off with that. 5 here 1, 5 here 4. So this is 1/4. So that was it for this question. I hope you did understood all the steps. If not, please leave me a comment. Remember to subscribe, thumbs up, and share with your friends. Thank you.